right, a very warm welcome to everyone. This is the November meeting for this year's Coventry branch. Just some housekeeping. During the meeting, if you're not speaking, could you please mute yourself? And you can always unmute yourself when you need to ask a question or need to make a comment. So today our talk will be on serverless architecture and containerization, and this will be presented by our own Rich Bishop. So Rich is a software developer. He's been doing this for many years because it started at a very young age. Rich runs a company called Orchis Ltd, and Orchis Ltd provides software and hardware solutions to businesses and charities. And these range from simple system integration through to full stack solutions involving custom hardware and software, to creating full end-to-end solutions and providing ongoing support for their customers. In addition to all these, Rich also finds time to be on the BCS Coventry Branch Committee, and Rich is our early career advocate. Well, should I say welcome? You're always here, Rich. Welcome, Rich.
Thank you, Jan and Bassi. Thank you. Shall I begin then? So for any of you who've turned up for a kind of hardcore, super technical session on this, I'm sorry to disappoint early, but what I'm looking at here is the more headline ideas of what is serverless and what is containerization when you think about software development. And I'm looking at it through the lenses that of us at Orchis. So who are we? So we're a software company based in Coventry. And as mentioned, we do all sorts of things. We work on lots of software projects, but we also do some custom hardware projects as well, working with a whole range of organizations, businesses, local charities, social enterprises. Lots of developers often talk about them being full stack. We like to say we're really full stack. We really will do kind of every bit of the project. And we can turn around things relatively quickly as well, which I'll come to in an example project in a bit. So yeah, so about me, I've been doing this for 20 years now. I started, I did it professionally for 20 years. I started as a hobbyist learning to code at 9 years of age, and many years later, I'm still doing it now. 20 years ago, I started working with clients to do this, and became self-employed and officially registered at my 16th birthday. Turns out I should have registered before that, but HMRC, or Inland Revenue as they were then, HMRC have forgiven me, so that's okay. Also a fellow of the Royal Society of Arts, fellow of the Institute of Entrepreneurship and Enterprise, the other way around, but a professional member of the BCS. I'm also work in a lot of business lobbying organisations as well, and I've done some work with the Federation of Small Businesses previously and the Institute directors, and I currently sit on Regional Council and the National Under 35 Committee and SME Council for the CBI. And so I expect to hear a lot about them next week, by the way. It's the big annual national conference on Monday and Tuesday. And I've done various things around the West Midlands Regional ICT Excellence Club, been charity trustee, etc. I like to keep myself busy if I can. Josh is my business partner and the technical director in Orchis, and he's worked on complex software architecture and big data and all sorts of mobile application projects professionally for well over 10 years. And he brings a kind of wealth of knowledge from those areas. It says here, from scripted task automation to custom kernel, hardware-based 3D acceleration to resilient infrastructure deployment, Josh is a jack of all trades and a master of large-scale back-end software development, deployment, and administration. And he really is. I'm yet to find a project that he and I can't take on between us. So what is serverless? What are containers? Let's kind of go through. So before we start, just a very brief history of the web, because we're going to be talking a lot about the web here, because that's our world, that's where we do a lot of our work. So start with HTTP at the beginning of every web address. It's the hypertext transfer protocol. It's the way that our browsers, our computers talk to servers to request information that they then respond. And in very, very simple forms, that's what you're doing all the time. You are sending a request and you are receiving a response. Sometimes that request goes with additional information, like you are signing up to something, therefore that request goes with your name, goes with your email address, and you get a response to tell you that you're successful. You're requesting the price for a certain product on an e-commerce website and you're receiving that back. It's basically what the web does. So in order to make that happen, when I first started out in web development, people would talk about, well, you need a web server that's always on. We need servers, so the servers we need to be able to cope with huge numbers of requests, all the requests that they might get, and you need the server to be updated with software, security patches, replace broken hardware, etc. And it was always talked about in the physical sense of a server. But these days, we don't talk about things in those terms because actually you don't necessarily need to worry about those kind of levels yourself because of the advent of what we now know as cloud computing. So if we haven't got our own computers, what are we using? And it's the cloud and the varying levels of the cloud. And I'll just go through now. So what we've just talked about is a typical on-premise solution. I've got a box, it sits in the corner of my room, and that's handling everything for me. You then move up to the infrastructure as a service. And at that point, an operator on your behalf takes over some areas of that and you kind of run on top of that, starting at the operating system level and working up. You've then got your platform as a service when you're just building applications and data on top of someone else's infrastructure that they've put in for you. And then you've got the software as a service, which is what most of us are more familiar with as the services we use. Any kind of web-based software you use, whether that's accounting, whether that's Facebook, whether it's any of those kind of web tools that you're using, that is software as a service. Someone is looking after every element of that for you. So for containerization, in-house within Orchis, we use the infrastructure as a service to host our own containers. But actually, we also use serverless technology as well, and I'll come on to that. And for that, we use other people. They provide the whole platform, and we just worry about the application layer and the data layer. Even though when we're using containers to handle our hosting and handle our client projects, our nodes, our bigger entities that are hosting these things for us are in the infrastructure as a service model, but actually every client project ends up in that platform. We only have to worry about the application and the data for each of those projects. And I'll talk a little bit more about that later on. So let's talk about serverless first. So basically you use a supported language and runtime, you deploy the code and point to some storage, often but not always hosted by the same provider, that storage, it can be elsewhere. And then the provider worries about scale for you. At that point, you just kind of just go, here's what I want you to run, go run it. No traffic, not a problem, code just sits there and used. Heavy traffic, no problem, the code gets replicated quickly and responds to those demands. But the key is you're just giving the instructions, you're just giving the code, and the rest of that infrastructure stuff we talked about earlier is all dealt with by somebody else. So here's a client example of a client that Orchis took on in 2021. So we're at BCS Coventry tonight. I know people are joining us from all over, but in Coventry, Coventry the city has been the city of culture for the UK in 2021. Because of COVID, it blended into 2022. So the actual opening event for that was in June 2021. And that was Coventry Moves. It was the big open air, the whole city involved, lots going on. However, it wasn't always planned that way. It was planned in all sorts of different ways prior to that, and COVID and the restrictions that needed to be adhered to just changed all of the plans. So this was for the Coventry Move signature event of the City of Culture year. And the brief that we were given by City of Culture was they're now not able to have events that attract huge crowds because June 2021, it was still very much around kind of keeping those large crowds dispersed so that you weren't kind of spreading the virus around. There'll be many smaller events spread across the city and there'll be stuff happening everywhere, but we want people to be able to enjoy the whole thing at home, a bit like a BBC News Live page. And so things are coming up in a timeline as they're happening. It needs to pull video from YouTube, as well as social media from all around the web. It needs to be as accessible as possible. We need subtitling, audio description, BSL translation, and we don't know the size of the audience, but it needs to scale. Oh, and you've got 22 days. Can you help? This was a genuine request we had from City of Culture Trust. Now, the good news is we did. We got to work straight away. We created a timeline of the posts and how we could work out how to keep that near enough live without the need for a user to refresh the page. It would be updating in front of them with accessibility toggles to ensure visitors always saw the version of content that was most applicable for them. And it needed to be massively scalable. Now, we didn't know whether the audience was going to be 20 or 20 million. We didn't know who was going to be tuning into this. It was all being turned around within weeks. The advertising hadn't gone out because there was no solution in the plan at that point. So we didn't know what the appetite was for this. We were very much going in blind. But as we were building this, Glastonbury went online with their live weekend, and it absolutely obliterated their servers. They had so many bottlenecks in people authenticating themselves to try and get in to see these various acts and artists going on. And that sent some shivers down some spines at City of Culture, who really did not want that to be happening to them. But luckily we planned for it. When we were thinking about how this was going to work and the fact it needed to scale, we'd already started thinking about making this serverless. We didn't want the bottlenecks of a server that we were responsible for. So what we wanted is small, lightweight. We wanted the code to then be deployed, and we chose Cloudflare as a provider for this, using their Workers and their Pages products to deploy this to 185 data centers around the world. No matter what happened, no matter what the volume of traffic was going to be, we were determined this was not going to fall over. So what does it actually consist of? Well, the entire application consisted of very few files, really. It contained two parts. One was the client application, which is what the public saw. It's just 9 files was all that was needed for that. It's all built in JavaScript. It was only run on demand, so it's still sat there now, nicely quietly putting its feet up, not worrying about it. And if we all visited it all at once, it would suddenly spark up and do what it needed to do. I don't need to worry about that scale. I don't need to trouble myself with worrying what that demand is. It's sitting there without me having to worry about it. That part rendered the visuals for the end user and then made API requests to the back end to keep up to date with what was going on, and it rendered the responses from the back end onto the user's screen. We made it extremely lightweight for speed, the idea being that you would never be more than just a few seconds behind what was happening anywhere in the city, no matter where you were sat anywhere in the world. And the back end for admin, for us to keep to manage it and responding to those API calls, it actually was a workers project that has just 4 files in it. And that was used to administer the whole thing and keep up to date with what the content needed to be, but then also have the API endpoints for the front end, so that anyone looking at it was receiving that live content as they were coming through. It only ran on demand, so only when we needed it to run did it run, and it responded to those API calls by either putting or getting the requested content from storage, and we've been storing it on Cloudflare's KV storage that they've got, so that's a key value storage. Very, very simple, easily replicable, and therefore spread around the world. And we heavily cached it, and I'll talk about that in a second, for speed. So this is what we kind of did, and the orange blocks here are basically where we put layers of cache around it. So you had an end user who was looking at the front end of the website. That was talking to our kind of worker that was working away to responding to those API requests, grabbing the content, bringing it through in the correct formats for the page to show, and that was just going off to a KV store, very, very simple database to do it. And what we did, as you can see all those orange boxes, is we cached at every level we could. And what that meant was that actually once we'd processed something, we didn't have to process it again. It meant that the response times were quicker and quicker the more people were viewing it, and the people just weren't being left behind. We got to the point where there were hundreds of items of content that were being put out during this one day, this one event that was happening that people were tuning into, and you didn't see any lagging on the system at all, because we'd built it in this way that it was always as up to date as it could be and cached as often as it could be. So where was it hosted? We didn't care. We gave it to Cloudflare, and Cloudflare looked after that for us. So we pushed the code up to them. and using Pages for the front end and Workers for the back end. They're two products that Cloudflare offer. At the time, Pages and Workers had only just become kind of more publicly available. At the point we were using it, it was still fairly new to be doing what we were doing. Now we've actually deployed a lot of projects using this same methodology, only because it allows them to scale so easily in a relatively cheap manner, without us having to worry about that infrastructure. Cloudflare worried about all that for us. It worried about the deployment for us, and requests were handled and responded to across the world because of that. Sadly, I've only got a record of the top 5. I'm hoping somewhere in the deep dark archive we've got something more than that. But we know that this code was run in data centers in Manchester in UK, in London in the UK, in Frankfurt in Germany, Paris in France, and Newark in the United States. Our code was being run at those points because it was the closest edge to the user that was using it. So they didn't have to worry about traveling through the web to get to wherever we were hosting it on our server, because we'd pushed it out to the edge of the CDN. They were getting a bounce off wherever they were. It was their nearest version of it. So what did it achieve? Well, here's an example of what it did. Now, what I've done, I've split the screen 4 ways here to show kind of the 4 different mobile views. But this was the 4 different versions of the content that was going out. We had the kind of the standard live version that was going out. We had a BSL translated signed version that was going out. Now, you can't hear the audio, but we also had an audio described version of it. And we had a subtitled version as well. So anyone who's watching this could watch it in their preferred way. And then up and down from there, I can't remember if I scroll through on this video or not. Probably don't, but you've got social media posts up and down above this, and we were keeping live with the audience reaction as well. As people from across the city were reacting on social media, we were able to embed those social media posts into this timeline, and they would be updating live in front of people with just a tiny delay of maybe a few seconds. But it meant that people were able to experience the whole thing from home, wherever that home may be, wherever in the world, near enough in real time. So some stats that came off it were that we hit 25,000 visitors during the hours that it was on. That resulted in kind of 26,000 page views, roughly what you'd expect. The load time was never more than a second. You were never more than a second behind what was going on. We handled 756,000 requests for information that was batting around. But then when you look at the total requests and the cached requests that happened within the system, we handled 3.28 million requests, most of which were cached. We only handled live 173 requests. Everything else, because those layers we'd put in, it was bouncing off caches rather than bouncing off our database, which meant that actually I joked afterwards that with that level of people, rather than even stretching its legs, the system didn't even really get out of its chair. And this was all deployed in a very simple way. And I'll confess now, I don't think I've ever told City of Culture this, it cost us $5 to host it. And this all happened, and that would have lasted a month. We only needed it for a day, but it would have lasted a month. It cost us $5 to absorb all of this traffic in real time, handling it within a second. Cost a bit more to build, but that was what the infrastructure costs were. A huge cost saving on what it would have been to have kind of put our own system in place and been able to react to that kind of scale and load. So let's talk about containerization now. Basically, I'm going to sum it up off the back of serverless by saying it's serverless with a bit more control. It's a bit beefier than what you do with serverless. Serverless is very small. You see there, very simple applications, very few files involved in the software, but sometimes that isn't appropriate and you need something a bit beefier. And to be fair, the majority of our work needs that. So we run in a containerized environment. You get to specify the system you're using in that container, and you get to put all your code in there with runtimes and install as many components into each container that you need to make whatever application it is running. You can also run many containers alongside each other, and done right, it provides huge portability to move systems around. So what is a container? Well, basically, they run on top of a physical server, on top of an operating system, and on top of an engine. So here's some graphics here. Kind of on the left is more of your kind of Unix style system, and on the right, you think more how Windows would be handling this. What you get is you get to share the physical infrastructure of the system. You get to share that baseline operating system, and you share the engine. And then the containers sit on top of that as layers within a container. They can use the things that are beneath, so they share kernels and things like that, and they can share kind of across other containers as well what they're able to use, so runtimes and things like that that can be used in more than one container. But they can't easily affect the others because they are all isolated. So what you're able to do is create kind of like a virtual machine environment where it's a completely isolated system off to one side, but in a really lightweight, quicker way of doing it, where actually you don't have to keep reinventing the wheel. You don't need the full operating system in every single one. You're not having virtual hard drives that contain entire systems. What you're doing is you're talking about the differences between your base system and what you're using. So how do you build a container? This is an example of a live project for us. So this is a Docker file that says to Docker what we need them to build. You'll notice it starts with a from, and you give it a from. I want to use this particular service, and I'm going to call it, in this example, it's Node version 12, and we're going to call it Node.js. And then straight away we start doing things like copying files in and out of it. We run certain commands on that system. We're then able to copy files out of the container, then go off and run a different thing. And basically it's a set of instructions. But what this is effectively doing is it creates an isolated environment for the code to run in off to one side, which doesn't touch your host system, apart from the files you're giving it access to, apart from where you've told it to store files, or if you've told it to link to other systems, etc. But if you don't tell it to do any of those things, it runs in complete isolation. But it's super lightweight. You can do, as a copy, you can run things in there. You can even specify entry point scripts to run. In this case here, we've got an entry point script. This is Docker. This is a Laravel application, and so we run things like the queue workers and things like that to make sure that queuing tasks get run. But we can do that just in a single run this shell script afterwards, and it runs it as soon as it's open. So that gives you an idea of how you build a container. You kind of describe where you start and you move on from it. It's all around inheritance as well. So you'll notice we are talking about, I want to use Node, and then later down we say we want to use the Orchis version of Laravel version 8 Mongo. So we've got a container that we share amongst different projects, and then what we do is we can build on top of that as well and do other things. So as an example, because we've got that Docker file in our project and I've got the source code on my local machine, this was me using this today, and I basically just run the script. Hopefully you can see the video playing, and hopefully it's not too blurry and small, but Docker build, tell it what container I want it to build using dot, so the files that are in here now, and it follows those instructions top to bottom. It goes and grabs that Node container, it goes, follows those instructions, it grabs that Laravel container, follows those instructions, and now it's created a container for me, which is on my system, and it's effectively, for all intents and purposes, a virtual machine. It's not, don't go telling anyone that, it's a container, but it is an isolated little box where it only knows what it needs to know. And I've built that very, very simply, one line, having given it those instructions. So now that container has all of the applications it needs, all the services it needs, and the files, and it's all bundled in there, and it can be moved now to wherever we want to run it. We can run it on this machine here, or we can run it elsewhere. And I'll just put a throwaway mark there. Can you imagine trying to do that on a whole virtual machine and being able to build it with the operating system, with everything else, making that as portable as this to then drop it somewhere else? It'd take a lot longer to do. The next demo to show you is the same one by the looks of it. So if I move forward, there we go. Is to show you about deploying it. And we've got a repository that we are pushing our containers to, and that's where we then house them ready to start hosting them. So give you an example of what it looks like to push the container up. So very simple command of docker push and then the name of the container. And then what that does is it runs through and pushes that up. And I'm just going to pause that there for a second because it's very interesting what it's just done. For those of you who spotted it, it's actually only pushed up the first 4 of, what must that be, 20 odd layers, because they're the only ones that's changed. Because we're always talking about inheritance, we're always talking about starting somewhere and then moving forward with it. Docker's very, very good at drawing a line in the sand and saying, okay, well, this container is using the same as these ones up until this point, so I only need to push the differences in this particular one. So the fact that this is a project which has a very, very similar architecture to a number of other projects we've got, the vast majority of the layers in the container don't need to be pushed up. They haven't changed. They don't need to be changed at all because we're using them in all sorts of different places. The only ones that are changing are those top few. So this is Docker's way of spotting those similarities between the container and the last time you uploaded it, but crucially other containers. It only pushes things that are different. So it uses minimal bandwidth to move that around, minimum of my time to move that around. I'm not having to wait for gigabytes and gigabytes for the whole virtual machine to move between where I am and where it's going. And it's using minimal storage as well, because it is only kind of containing those small changes that are being used, rather than having to control and store the whole virtual machine. So thinking about that layered approach, and what do I mean by layers? Here's an example. It's fairly loose. It's not all the layers are in there. It's just for kind of illustration purposes, really. But when we start at the bottom, we're talking about kind of, first of all, sharing the system kernel. So straight away, a lot of the things that these Docker containers are doing are able to access the kernel that's in the host system. It means that they don't have to worry about holding all that information themselves. You can then build an operating system on top of that. Normally, you just specify that I want to start with Debian or start with Arch or something like that, and you can then have a virtual version of that operating system built on top of the system's kernel. Again, in isolation, its own version. I'm then using the example of PHP because it's something that's used across lots of our projects. And so straight away, we've got two layers that basically we could say all of our client projects are using. It's not true, but for this example, we're saying that. Then we might split it. So depending on how we want to direct the traffic, there's two ways of doing that for a web server. There's more than that, but there's two kind of big ones and ones that we use, Apache or Node. And so straight away, you can say, well, I want PHP and Apache, or PHP and Node. Sorry, it shouldn't be Node at that point. Sorry, it should be Nginx. I do apologize. I put the wrong thing. But anyway, for anyone who knows web, you know what I mean. So it should be Apache or Nginx at this point, and you can branch out into those different versions of that. Then you can build straight on top of that. So Client F as a project that's listed on there is then built straight on top of that. But actually, some of the other client projects we've got need more than that. So we're going to put Laravel on top of it as well. And actually, some of them want Laravel with Mongo, some of them want Laravel with MySQL. So actually, we can take the base system and then update it to what we want Mongo or MySQL, how we want it to use Mongo or MySQL. And on top of that, you can go again. You can add another layer onto it. So one of our projects uses the GD graphics library. Well, we can add that on at that point there. What it means is lots and lots of these projects are similar all the way down. And we can do this layer by layer. We can inherit on top of the other. So when we're building client C's project, it's going to be built on top of GD library, on top of something that we've already built elsewhere. So all those layers that you saw going up a minute ago when we were uploading, the vast majority hasn't changed. It's just the bits at the top that have. And what we're able to do is specify for every single client project, we can specify a slightly different setup. And actually, there are some of them where the only thing that changes is the code base and the setup is identical. Makes it super easy. We can just reuse containers, no problem at all. But sometimes, as demonstrated here, you've got certain libraries and certain bits of information you need, and therefore you can expand further and add more stuff on top. So then how do we host them? Now, this is something that we've done ourselves, and there's lots of solutions out there. The big buzzword one, and the one that most people talk about, is Kubernetes. That's a way of kind of housing containers, especially in Docker containers, and then managing them. There's lots of different versions doing this, and I keep saying Docker containers. There are many different types of container as well. I talk about Docker because it's what we use internally, but lots of people use lots and lots of different containers, and there's lots of different ways of skinning this cat, if you like. But what we do for us is we start, I mentioned earlier on about using that infrastructure as a service idea. We use nodes that are basically infrastructure as a service to hold our containers. So each node we have is basically a virtual machine, and within that virtual machine we host many containers. On the diagram here I've put like 2 on each of them. In reality it's hundreds spread across all these, but just for the point of demonstrating it. So you can see all those client projects that I was talking about in the previous slide now dotted around across those. And I've got node 1, 2, 3, but I've also got node ... x, because this could go on forever and ever and ever. And it doesn't have to be limited to a certain number. You can just keep adding extra nodes onto it. So what we do is we handle these containers on these nodes. We can also move the containers between the nodes. And there's a terminator at the beginning, which actually handles the traffic and where it's going. So in the example I put on with the big black line there, there's a request and response going to and from a web service, which is ArtSpace in this case. The terminator is using the register of containers database to effectively just a database to work out where the containers are, and then diverting the traffic in the correct way to the correct container. Now, it's not just HTTP traffic. We also do things with MySQL traffic and other bits of traffic that we move around between the containers as well. The idea being that a project can be spread across multiple containers and multiple different parts of a project, and they could be across multiple nodes. And we've got something that's able to create the communication channels between those things. Now, that all sounds very, very complicated until you think about the fact that what it means is you can always keep track of where containers are and point traffic at them. But it also means if any of those nodes become overloaded or broken, or something goes wrong with them for whatever reason, containers can be moved very quickly. Those client services that we're running on their behalf are moved around these. So as one node becomes super saturated with traffic, actually it doesn't matter. We can offload some of the other containers that are on there so that they're not affected by that. It means then we can add an infinite number of these nodes if we wanted to, and move containers for as much as we wanted to. But also at the point where that traffic then goes away, that demand isn't there and everything's gone quiet again, you can shrink those down again. So you know what your minimum levels of capacity should be as well. And you can say, well, this one, we've now got 3 or 4 servers running at just 10% of their capacity. Let's amalgamate them into each other and we'll get it around 30%. And we might want to push it back out again, meaning that we're only ever paying for the infrastructure as a service level that we need. We're only ever paying for the number of nodes that we need, and we can shrink that down when we no longer need it. And that orchestrator in the middle there is the thing that's kind of handling all that for us. It's keeping an eye on the nodes, keeping an eye on what's going on, and moving those containers when it needs to. Equally, if a container breaks, it can reinstate that container, and we kind of end up with a situation where we're not quite at the point where it's 0 downtime and 100% reliable yet, but I'll come back to that in a bit. We are working towards that. It allows us to do that. So yeah, why do we do it? So one of the key things for us is portability. So we don't need to worry about what systems our container is running on, because the container contains everything it needs to run. So actually, we've got developers who have worked with us who are running on a Windows system. I'm on a Chromebook, for instance. Josh is on a Linux machine. We've got people who work with us who are on Macs. It doesn't matter. We don't need to worry about them all installing individual components. They don't need to worry about PHP versions or MySQL versions or anything like that. In every single one of our software projects, we have a container file which says, this is the environment that I need. And I'll talk about that just a little bit more in a second. But as long as they've got access to a Unix kernel, which on Mac or Linux or me on my Chromebook, absolutely perfectly fine. On Windows, they've got the whole subsystem thing now, and Docker run really, really well on there now. Didn't in the early days, but absolutely does now. They've got access to that kernel. It means that they can run these containers on top of that. The person developing now doesn't need to worry about their setup anymore or how they're going to direct traffic around their machine. I know there's still some things around firewalls potentially, depending on what you're developing and what you're doing, but the majority of what you're doing is now in there. And it also means you can have 4 or 5 projects open, even if they have different PHP versions. They require different MySQL versions. Some have got Redis, some haven't. Some have got Memcache running, some haven't. You've got different tools that might be running for each of them. So we've got mail handling tools like Mailhog that we use to see if emails are being sent correctly. It's like a fake inbox that we use. Again, you can have many versions of those running at the same time. Whereas if you were doing this in a more traditional way of installing everything on your machine, that would be really tricky to manage. And it also means that we don't have to describe to anyone who's taking on a project what they have to set up. We haven't got a set of instructions that say, oh, well, you're going to need PHP version this and this and this, because the container itself, the instructions for the container contain all the information it needs. It runs without us having to worry about all that. So as long as you have access to that Linux kernel, it's fine. Everything else is built on top of that kernel. And it makes expanding our capacity easy. As I said before, we can just add more nodes to our hosting capacity and move them around. And for developing, we can pull down to work machines or work on the same system at the same time without having to worry about those dependencies that are set up. So portability is really key. And as an example, this is for that same project again, and the code on the left-hand side there is a Docker Compose file. Now what that does is that sets up not just one Docker container, but many. It's a set of instructions written in YAML that says, these are the services I want, these are the environment variables I want you to put into this, so that you can set default root passwords for databases when you're setting up. You can even set database migration scripts in there if you like. So if you want some core data to go along with your MySQL container when it's started up, you can set those in there. You can point it to, we've got the Docker endpoint shell script written in there. So again, you've got things where you can run scripts as soon as a container has been brought up. And within seconds of me just typing Docker Compose up, all of these services are available on my machine. Now, it's within seconds for me because I have these containers, or at least some of the components of these containers on there. If I don't, it's fine. Docker handles that for me. It goes and grabs what I need from where I need it and says, right, well, I haven't got that layer and I haven't got that layer, I haven't got that one, so let me go grab those. Right, I've now got enough, let me push through and build it for you. And I'm not having to worry about any of those. I can kind of work alongside kind of other developers and their containers that they've created or the services they've created, and just have it all come together without me having to worry about any of the installation. As long as I've got Docker installed, and as long as I can run that command, the rest of it's done for me. So as I mentioned, we can do then many versions of PHP, MySQL, Mongo, Laravel, Node, whatever you're running in these. I'm talking very web heavy because that's the world I'm in. But you could be running anything in these. You could be running an isolated browser. You could be running a kind of LibreOffice or something like that in there that's going to run on a kind of Linux-based system. You could be running in an isolated container off to one side, so it doesn't have access to anything you haven't given it access to. You could be running any kind of shell scripts or even Python scripts or anything you like within these without an issue. I talk a lot about web because that's predominantly what we do an awful lot of, but you could run anything within these. It means we can drop in and out of projects with ease, just change which folder we're in, change which, so for us it's Git, we use Git repositories, change which repository we're in, run that Docker Compose up, and my machine is set up as the same as it would be on the server, on the live environment, so for me to replicate exactly what we're seeing on live here, because we are just moving these containers around. And then just at the bottom there's a screenshot of showing what the kind of the number of containers that are opened by that simple script there. So I'm suddenly running those 6 different services on my machine, all isolated off. You can notice they're all prefixed with ArtSpace because that's the project I'm in. I could be looking at 5 or 6 projects in a day, in which case I'd have like 36 of those running. And they don't interfere with each other because they're all off to one side, they're all isolated, but also sharing those layers of those containers. And efficiency is a big key as well. So I mentioned around kind of bringing up nodes and shrinking them back down again. We no longer have to think about dedicated server and dedicated hardware. Often people were very concerned around kind of virtualization and things like that, around the limited resources you had. And so went down the kind of dedicated route or the co-hosted route to manage their own physical infrastructure. We don't need to worry about that. In fact, apart from what we've actually built as a hosting platform for this, we don't really need to worry about virtual machines either. We do in the form of our nodes, that we do need to think about that. But actually, once we're building applications, we don't need to worry about it anymore. We don't need to think about virtual machines or anything like that. We just need to describe the conditions that this application needs to work, and that will be built into that container. Containers are much lighter weight, as they only contain differences based on your base kernel, and they only contain those differences to mean that you can run without having to worry about all of those other dependencies. And it means more services are running on fewer machines. We can run those without the big heavy weight of dedicated RAM or dedicated CPU being given to each of these virtual machines, because they're containers amongst each other. Now, you can still put limits on them if you really want to about what they can and can't access. You can limit their CPU access, limit their RAM access if you want to, but also you can kind of throw them into a wonderful container soup, if you like, and they can fight amongst themselves. We do a little bit more management than that, but you absolutely can. You can just keep running these containers next to each other. With virtual machines, you've often had to specify how much RAM is going to be given to this particular virtual machine, or how much hard drive space is going to be given to this one. Again, you don't need to do that in a containerized way. So we have more services running on it on fewer machines. And that not only saves cost, and one of the things I've put in the synopsis for this talk was talking about the kind of the environmental impact of this as well, but it saves cost. We now run hundreds of our client web services on just a handful of these virtual machines. Our hosting bill is a fraction of what it used to be, because we used to try and isolate our clients by having them on separate virtual machines on infrastructure. Now we can isolate them by having them on separate containers within the same virtual machine. We've drastically reduced our kind of real estate, if you like, of those virtual machines. And because we're running fewer of those nodes, fewer of those virtual machines, and we're using less power and less energy, we're also emitting less CO2 as well. The environmental impact of squeezing more things into these resources is huge, and allows us to do much more with that. So where to next? And I've alluded to a couple of things as I was talking through of where we kind of want to go with this ourselves. So there are still some of our services that we haven't containerized yet. We've still got a couple of legacy systems around, which is just going to take us some time to create the correct container for them. And at the moment, it's one of those where I don't really want to touch it because it's working and it's working brilliantly. But at some point, we do need to think about it in this containerized way and bring it on board with the rest of our hosting infrastructure for its benefit and ours. Putting something taking something out of its own dedicated virtual machine and putting it into a container and putting it amongst bigger resources, more resources available to it, helps it to be more efficient, etc., but also helps us to reduce cost, drop another machine off, etc. One thing we want to do in the future as well is some of the updates that need to be done at different layers of these containers. So different bits of applications do need updates as they go through. And at the moment, that's still quite a manual process for us. We do host, for example, a lot of WordPress websites on behalf of our clients. We don't do a lot of WordPress development ourselves, but we do help support people who are doing lots of WordPress development. And so WordPress gets updates all the time, and we've kind of containerized it as best we can, but there are always those updates that we need to run through, and we're working really hard to make that updates scheme as simple and easy as possible. We're not quite there yet, but we want that to be a semi-automated process. At the moment as well, we're not taking advantage of the idea of replicating containers when we handle high loads. At the moment, we're moving them around into nodes that can allow them to cope with that higher load. But in the future, we want to be able to split traffic out and be able to replicate services so that we load balance across multiple versions of it. That's an ideal scenario for us, and it actually is fairly achievable. It's just something we haven't spent time doing yet. And we also haven't got to the point of zero downtime. When we are refreshing containers because new versions of the software are being uploaded, we are having those few seconds of downtime while that happens. Again, being able to replicate them next to each other, run them at different versions of the software, maybe even get into the realms of A/B testing users, where one set of users see one version and one set see another, is an exciting prospect for us. We're not quite there yet, but we will be. And then the idea to offer this as a service to other developers is absolutely on the card as well. Taking the headache of that kind of web hosting, web infrastructure away in a kind of really nicely controlled, because you've got that control around the containers, but also freeing way of not worrying about it. So that's me. That's my very quick run through about service architecture and containers and what we're doing at Orchis. I've now spoken for, I think, 45 minutes, so I can only apologise to all of you listening that you've had to listen to that. But I'd like to throw it open to any questions, if that's okay. Is there anyone out there that would like to know anything?
Hi, Rich. Yeah, it's John here.
Yeah. Hi, John.
You put up a slide showing the clients on the nodes. It's got a terminator. Is there only one terminator, and is that potentially a single point of failure?
It is at the moment, yeah, to be fair. So actually, one of the things we are trying to do at the moment is replicate that terminator. We have at the moment, it's fairly beefy, and we haven't had any problems with it at all yet. But you're absolutely right, it is a single point of failure at the moment. I should have added that to our where's next list of being able to, again, replicate multiple terminators to be able to then direct traffic around. But no, well spotted and absolutely spot on.
It's life in the old dog, yeah.
Yeah, yeah. But you're right. That removing any of those kind of single point of failure type things, we need to work on more. But actually, going down this route allows us to experiment with that.
Yeah, cheers. I've got another question, if nobody else minds.
Yep.
You mentioned YAML.
Yes.
Is that widely used now? Because I only came across it when I was trying to use Android Studio.
Yeah, I mean, it's used, lots of configuration files use it as a way of doing it. Yeah, it is fairly widely used. Yeah,
So I'll tell you why I'm asking. I obviously cut my teeth on Make.
Right, okay, yeah.
And before that, we didn't have anything like that.
Yeah. There's a question around the orchestrator. Did you want to unmute yourself and ask about that? No. So the question was, oh, okay, no problem. Your mic isn't working. So is the orchestrator always necessary? It is in the way that we're managing it at the moment. In that we've got one system like the orchestrator that sat there monitoring everything for us and making the decisions for us. I guess there are alternative ways of doing that, where you could potentially make containers self-aware and move themselves around. But for now, for that just extra level of control, that's what we've got sat there doing that. So it's working out where things need to be and balancing all of that for us. But you're right, there might be other ways of achieving that. Has anyone else got anything else they'd like to know? Feel free to unmute yourself or add something into the chat.
Hi, it's James here.
Hi, James.
Hi. In terms of APIs, what type of framework or patterns do you use to manage your request and response?
So we tend to go RESTful. So if we go back to the serverless bits, we'll go for a RESTful API with those. So all of that content that was being shown up on there was just it was the front end was just requesting from the API mostly what have I missed since the so and so time, and we're able to then reply back with that. And then the whole architecture was written in JavaScript, so it was just passing JSON objects around while it was doing that. Does that answer the question, or was it
no,
more technical?
No,
that's fine. I didn't know whether you wanted to get more geeky and technical than that.
Well, yeah, no, it was just in the terms of serverless. I was just interested, because in terms of how you're managing that API gateway. I was kind of interested in that in context of serverless. If there's any gotchas that you've come across, really.
I mean, in this particular application that I used as an example here, I mean, there wasn't anything to worry too much around kind of permissions or kind of authentication. It was a public platform that anyone in the public could use, and so you do obviously have to think about what you do around kind of what tokens you need to pass around in order to make sure you're only sending the right information to who. But in this case here, I guess I've chosen a fairly easy example of it was just a case of what should I be showing my user? Go off and grab it and bring it through. And again, just the bit that was really exciting around using Cloudflare workers and Cloudflare pages for that was we didn't have to worry about the infrastructure at all, and we also didn't have to worry about the caching architecture. We just kind of told it to do it. So we just said, right now, once I've run this, just hold it in your cache and off you go. And it means that we've got so much of that still all cached and built up because it won't ever change. We took a kind of an easy route with that, I guess. And so a lot of the API calls were just actually responding back with stuff from cache rather than having to recalculate anything.
Okay. No, thank you.
Hi, can you hear me?
I can, yes, far away.
Okay. A question about the orchestrator. I think is a slide. How do we host them? If you are going to lose one of your clients on node A, for example, how you're transferring the services to other nodes? What kind of redundancy is in place?
So I'm going to bring up the diagram if I can. There we go. So obviously I've given a very simplistic view of what this looks like. So alongside each of the containers, there will be obviously the container that's running, in our case, a web application. Then there'll be one that might be running the database and one that will be running maybe a cache service or something like that alongside it. So when I've just simply put ArtSpace or client B, actually I'm kind of hiding a lot behind that. There's many containers. Each of those is then going to a kind of network available storage and mounting that storage within. So all of those nodes have access to that storage, and it's all managed with various locks, etc.
So
you require it to.
You're setting the resource from the storage.
So some of the resources some of it's within the container, but anything that is kind of user generated. So any files that are being uploaded from the storage, any that needs to be stored, anything that's in the database, obviously they're being stored because that's stuff that's going to change and needs to be available to any versions of this container if and when it moves. But actually a lot of the source code that runs the application itself is contained within the container. So you can just pick that up, move it. And so it's only what it needs to refer back to from a database point of view, what maybe users have uploaded or what's unique to various records that are in the system, if that makes sense. Yes,
so if it is like an application specific to node A and you're going to lose node A, then the service provider manages this.
Yeah, so what we'll know, so what we'll pick up on is where either one container or many aren't very happy. So we'll start picking up on errors that are being generated, where they've maybe stopped responding as quickly as we want them to. And if that's an isolated container, then it's a case of let's refresh that container. And if it doesn't work on that node again, let's try that same container on another node. And then it starts escalating through, okay, I need to go ring for help and let's get a human involved at this point. But it could be that the node has become sick for whatever reason. Whatever can happen with these things, at which point again the orchestrator will go, actually I'll just abandon that then because I can't do anything with it now, and so that node's gone. So what I'll do is I'll spin up these containers off to this side on a new node, and I'll tell the registry of containers where they all are so that the terminator knows where to point the traffic to now, and then that node can then die a slow painful death as it's looping around whatever it's looping around, etc. But the services are very rarely interrupted. If they are, it's for a matter of seconds while those things happen. And again, one of the future aims of what we're doing is to have no downtime at all while it's happening, but we're able to kind of do that in seconds already automatically.
Oh, brilliant. Thank you very much.
Can I just ask a question linked to that,
Yeah.
in that case? So if a node's falling over, and a client is trying to secure its data, is that data coming off the node and going somewhere safe? So when the client's spun up in a new container on a new node, it's still got its data, or is there a potential for losing data?
No, so the data is stored separately on a storage service. So again, I've made the graphic a bit too simple maybe, but there is a storage service that each of these containers are connected into. So the storage isn't node specific, meaning that these services all then share storage in the middle. So when a container is put back up on another node, it can then link into that storage that the previous one was using. I guess there is a scenario where potentially you could end up with file locks that aren't unlocked, but the kind of things that are being stored by these are kind of being generated by users at that point in time, and you're likely to only lose a single entity of a single thing rather than massive data corruption. So although it's more than you'd ever want to lose, it's kind of an acceptable amount of, oh, well, that request didn't go through and didn't complete, so we've kind of lost that one. What we haven't done is lost the entire database or the entire file system.
That's excellent. Yeah. This is the sort of thing I used to have to worry about when I was working.
It's the sort of thing I've worried about for most of my adult life, and so being able to sleep well at night, knowing that we've kind of got that in place, and also just to reassure any of our clients that might be watching this, on top of all that network storage behind, we've got the regular automatic backups and things like that as well. So again, if worse things were to happen, we've got all that in place, ready to bring that back. So we haven't quite properly war gamed it yet of trying this, but in theory, even if our infrastructure provider, which is AWS, as lots of people's is, even if that went offline, in theory we could start up again on a different cloud provider. We'd have to worry about some of the traffic routing to get to the terminator, but in theory we could just pick everything up and move without too much hassle. But we're yet to test that, and fingers crossed it doesn't ever need to happen. But I would also say if AWS completely goes down, then we've all got bigger problems because most of our infrastructure in the world will suddenly stop working. So, but yeah, it allows us to sleep safely at night as well, knowing that we've put all these kind of checks and balances in place.
Okay, thanks.
Another question to ask.
Yeah, sure.
How the service provider is handling the GDPR data from the individual clients and the right to be forgotten and everything like that? Is it like, have you got specific terms of how the client information is processed and deleted or disseminated elsewhere?
So the thing about GDPR that I think some people get hung up on is the idea that it's a data-driven, a digital-driven process. That, to me, GDPR is always a business logic process. So it's about how you work with a client to understand what their business process will be around GDPR. How are they handling, or how do they need to handle right to be forgotten? Because again, to do that generically across the board wouldn't be safe or correct. There are organizations we work with, like charities, who work with young people, and therefore they have to keep records for 70 years, regardless of what the rest of GDPR says. So for us to say, oh no, we're going to wipe everything clean after 2 years, that just wouldn't work. So we have to work with every client at an individual level, and an application level and a business level with them to work out what their policy needs to be. It's not something you can kind of do a one size fits all, this is what database retention looks like.
Right.
If that makes sense.
Yes, it does. Thank you.
All right. Any other questions? Oh, thank God.
I think we might be done by the sounds of it.
Yeah. And thank you very much, Rich, for the this very interesting and informative talk. Worthy of note is the portability and efficiency of the containers, and not to mention the low infrastructure costs, and of course the environmental impact. I think I did hear something about reliability and availability there, but I think we're saying, well, we might that's not been very well tested. Although if there's an issue, then we do all have issues. We will all have issues with that. And just to thank everyone for the questions, and these questions have enhanced this talk. Can we give Rich a round of applause? You can do it physically, well, clapping, or you can do a virtual one as well. I'll do both.
Thank you very much. Thank you.
Thank you. Thanks again.